Thank you, Debbie. Good afternoon, colleagues. I welcome you to this webinar aimed at providing an insight into drone technology, digitization, as well as AI and the applications in our industry. My name is Ruben Govender, and I'm the current chairperson for the IT division. Over the last few months, a lot has transpired. The way we work and deliver services, interact with our teams, clients, and partners have all changed due to the COVID-19 humanitarian crisis. We had to react and adapt quickly to stay relevant in these new realities. And some of the steps we have taken during this time include ensuring the health and safety of our families, our staff, clients, and partners, as well as the adoption and investment in new technology and systems that facilitate remote work and delivery of services. The focus of the IT division is to add value through educating our industry on new technologies, on new developments, for instance, the adoption of 4IR, both from a hardware, software, and human perspective, and to reimagine how we do things through 2020 and beyond. We as an industry need to build competencies and invest to be more digital and data-driven, to utilize technology to redesign the way we work. And we can't just focus on reacting or coping with the unfolding challenges presented within our industry by this epidemic. But instead, we need to look ahead for opportunities to innovate during the rebound. To that end, I'm going to keep this short so we can get straight through to the webinar and to the content. I will hand you over to Dayle Pedro to introduce you to our team of panelists and proceed with the discussions. Thank you.
Thank you, Kuben. We do appreciate that introduction. Good afternoon, panelists. Good afternoon, attendees. It is great to have you all here this afternoon with us, discussing a very exciting topic, one that I know a lot of people are talking about. Maybe just a quick introduction. I will be your moderator for today's discussion. And yes, so just a quick introduction to who I am and how I fit in this space. My name is Dayle Pedro. I currently have 4 years experience in commercial management and integration of technologies in complex sectors, such as the engineering one, specializing in remote sensing and digitization. I'm also a remote pilot license holder issued by the South African Civil Aviation Authority, and have about 100 hours plus flying complex infrastructure for inspection purposes and large-scale aerial mapping. Today, I'm joined by some of my esteemed colleagues in the sector that have combined about 50 years experience in the engineering sector alone, and have been the pioneers in effectively integrating technologies in the engineering workflow to derive project cost savings and to collect better information for more informed decision-making. The first panelist I'd like to introduce is my boss and business partner, Darryl Epstein, the Managing Director of DeltaScan. The next panelist I'd like to introduce is Richard Matchett, the Digital Practice Leader at Aurecon, who has done some great work. Next panelist I'd like to introduce is Louis de Klerk. He's the leader of reality capture at Aurecon. And our final panelist will be Grant Harli, the technical director at Jones & Wagener. Right, to get to the topic of today's discussion. Guys, I'm pretty sure we've all been discussing COVID and you've heard a lot about it. It's all in the news, but sometimes one needs to dwell into understanding how does this affect my environment specifically. And the topic of today will be the post-COVID, why drones, digitization, and artificial intelligence are needed now more than ever. Debbie, is it okay if we can just quickly run the first poll before we start, just so that we can get an understanding of the attendees in which specific AutoCAD versions they are currently working in? Guys, are you guys currently still working in 2D? Have you already started working in 3D? Or do you integrate both in your current workflow? If I can just allow, let's say about a few seconds, just so that I can see some answers. And Debbie, if you can share the results, please.
Okay, people are still voting. but it looks as if both versions is coming out at about 48%, and 2D AutoCAD is 33%, and 3D AutoCAD is 20%.
Interesting.
So I'm going to leave it open.
Okay.
Okay.
Oh, that's very interesting results.
Great.
Panelists, I hope you've taken note of the results, just to show of where the key points of discussion must be had. Okay.
Okay, I'm going to end that for now.
Okay. Thank you, Debbie. Okay, ladies and gentlemen, as we know, the post-COVID conditions currently in the market have been devastating. One needs to only look at what's happening currently in the news to know that it's not really a great situation. But I mean, as pioneers, we always constantly look forward and ways in which we can alleviate ourselves from the current condition. Deloitte has released a paper specifically drafted along understanding the engineering workflow and how it has been affected by the COVID. And it reads as such: companies across the board will have to contend with decreased demand as governments face rising deficits and residential and commercial projects are dampened by the unemployment and low GDP growth. Although some companies may be able to execute on the backlog of projects, the pipeline is expected to be weak for the foreseeable future. This suggests the following: construction companies with high levels of debt and low cash reserves may face a liquidity crisis. As small businesses, subcontractors may fail rapidly. Contract management will come into sharp focus as customers seek to terminate or renegotiate contracts. And I know this has been a lot of the discussion, but one of the key things that a lot of people have been saying is that to consider if the crisis can be used as a catalyst to rethink how work is done and to accelerate adoption of digital capabilities, specifically in the three phases of engineering, one being the planning and design, the construction, as well as the operational and maintenance phase. Now, quickly to speak around the technological pillars that we'll be covering today is, we are currently living in a world where there is a paramount amount of data around us. It's data, data, data. There's just more data. But you know, us being pioneers, the best way of going about this is converting that data into knowledge, identifying the trends and patterns, optimizing the operations based on the trends and patterns one could extract. And then the final stage being the real-time decision-making process based on the more efficient data one has achieved. It's at this stage that I want to hand over to our first panelist, Darryl Epstein, where he will be discussing some of his work that he's been doing in the industry, specifically around the engineering workflow. And then from there, we'll be moving along to the rest of the panelists. Darryl, if I can hand over to you, I'll just stop sharing my screen quickly.
Cool. Thanks, Dayle. Okay, I'm going to just jump on my screen as well. All right. Afternoon, evening, everyone. Thank you for joining. I'm very excited to have everybody here and to share some of the work that we're involved with. And really, what it's about is education. You know, getting the industry educated on what's going on in the market, what's happening elsewhere, overseas, and how to, you know, swim and make it through these post-COVID times, and how digitization plays a part in that. I'm a civil and structural engineer by profession. I started in contracting, I moved into design, and during my design stages, I fell in love with tech. I fell in love with innovation in the markets. I love designing, I'm passionate about the designing aspects, but I fell in love with 3D. And that's one of the main reasons why we started that poll. And I'm going to go into that a little bit. So what I found when we started using tech, we started using drones early on, simple means to take photographs, get to elevated spaces quite quickly, quite cheaply, and efficiently. And all of a sudden, this 3D market started coming through to engineering. A process known as photogrammetry, digitization, and LiDAR all started sprouting up everywhere. And it really changed the game. But what we found is that it was one thing to have a 3D model. It was one thing to have a nice LiDAR point cloud or a drone scan. But what do you actually do with that information? How do you consume it as an engineer? So DeltaScan was really created when we started creating customized tools. We started focusing on the engineering market, on our professional backgrounds, and seeing how do we fit this in? You know, how do we take this to the next steps? We pulled away from, or I pulled away from being a consultant, and I created an independent entity known as DeltaScan. and we provide tools to the engineering market. That's our main target customer, which is bringing integration of digitization and different technologies into the engineering sector. So very quickly, who we are, I've kind of touched on that, but essentially we focus on 3 areas. We really about data analytics. We're not a drone company. We don't own or fly or operate drones. We take that information and we turn it into engineering value. So we focus on 3 things: inspection, which is all about speed, information, and accuracy. We focus on the digitization workflow, which is BIM, which I'm going to go into a little bit, and the survey and GIS type of work as well. I'm going to go into all of that in the next few slides. Very quickly, what I like to touch on is compliance. I know some of the other guys on the call will probably go into it in a little bit more depth, but to start out, it's important
Darryl,
to
interrupt. Is your screen shared?
1 second, is it not sharing? Okay, let me just jump on there. Okay, sorry about that. I don't know why it didn't share. So, all right, very quickly, compliance around the tech. What is it that we do, and what are the tools that we make use of? To start out, the CAA is very, very well known in the industry. They regulate air traffic. And when you start playing with drone technology, you start toying with air traffic, commercial airlines, and you're invading the same space. And therefore, it's a highly regulated market. There's a lot of regulations and restrictions about where you can fly, what you can do with it. So what it essentially is all about is having an ROC. There's 64 companies in South Africa that are legally able to provide drone data collection services. We aren't one of them, but what we do is we make use of those 64 companies. We have a massive network of pilots, of guys that we can pull into. Why that is really beneficial is we're not geographically limited. It means we can mobilize to sites very quickly anywhere in the world. And we can also regulate the pricing because it's a cutthroat industry out there. And we know, what's available, who has what hardware, and the different skills for different jobs. Very quickly, there's a lot of very exciting drones on the market. They each do different things, but they basically carry your top of the range modern day sensors, your top of the range cameras that you can use in movies. You've got specialty payloads and many different others. Why we turned to drones initially is, well, it's really the most accessible and cost-effective means of collecting data. If you're comparing it to your scaffolding, your cherry pickers, your rope access, it is very, very, very effective. Different camera systems we make use of. I'm not going to go into too much depth right now. What's important to touch on is the technological progression. And this is the progression of comfort levels. It's really, really important to understand this. Starting out 20, 30 years ago and much further back, everything was done by hand. This is your engineering office. It's about hand drawings, calculators, rulers, and pencils. And the limitation with hands is that, well, it's not so easy to make changes and it's not so quick to get information out. The next progression went into CAD. CAD came into the market and it provided efficiencies. It provided adaptability to changes because all of a sudden you can just delete a line, add a line, and you've made the change on your drawing, on your design. And this is where a lot of the market got very comfortable. It took a big, big step to move over to computers. There's a lot of resistance. And the next change that happened after that, and the change that we currently experience, is 3D, three-dimensional designing. And that's really about BIM. That's about integration, and integration being the key component that you can start fusing your information. You can start fusing your workflows with other disciplines. MEP, plumbing, electrical, architecture, engineering, now all work together. There's a really, really powerful synergy that comes together when you start working in the 3D environment. And what's now started happening is that 3D has become the norm. A lot of companies have adopted the 3D workflow, and the next revolution that is coming out of that is what we call 4RR, or four-dimensional designing. We're talking about things like virtual reality, augmented reality. And what 4RR is about is 2 things. It's automation, bringing a lot of automation into the workflow, as well as optimization. Now that we're doing our designs, how do we optimize the way we do it? And Post-COVID-19, this is more relevant than ever, because what we're really looking for is, how do we optimize the way we work now? How do we go forward in this new era? So what we focus on is photogrammetry, digital workflows. Essentially what it is extracting depth from photographs. We take photos with the drones or from handheld sensors, and we reverse engineer what those photos seem. It works the same way that the human eyes do. One eye perceives colors, two eyes, because there's a gap between them, because there's a space, your brain can make out the depth of an object. The same reason that all modern day smartphone cameras have more than one lens. It's all about depth extraction. And when you apply that to photography, you can reverse engineer 3D. You can reverse engineer engineering information. So we focus on infrastructure, and infrastructure is our game. There's a lot of other uses for drone. There's surveying, there's surveillance, there's cinematography, there's agriculture. Companies that have embraced this tech are many, and this is one of the big fears in the market. You know, who's using it? How do we use it? Does it work? It's a technology that a lot of people are afraid of. But what I like quickly to start out, surveying. Surveying has never been the same. Survey workflows are changed forever because of drone technology, being able to cover pieces of lands unlimited in size very, very quickly, and being able to generate very powerful 3D models and getting information from that. Starting out, you can get very high resolution, huge area maps. You can generate DSM and DTMs, getting your terrain, and then you can start doing planning for stormwater and designing on site. This is a very powerful modern day workflow. The second aspect is what we looked at as scan to BIM, basically taking an asset and digitizing it, turning that into a format where you no longer have to be on site. And this is really the most significant factor when it comes to COVID, because all day long our phones are ringing. How do we do inspections? How do we do engineering and design without going to site? Can we stop sending our teams there? So a very quick intro, what it looks like is a short video I've got here. This is a commercial block. It's a shopping center. What you see on the screen is a digital replica that was created using a drone. But this took hours on site. It was done within half a day of data capture. And what we're able to reproduce is an exceptionally accurate point cloud, an exceptionally accurate digital replica that you can integrate into any one of your modern day engineering design packages. It integrates into CAD, into Revit, into Civil 3D, and many, many others. And then this right here is the workflow post that. How do you turn it into an engineering drawing? How do you make that information accessible for council submission drawings, for renovations, for planning? And this is the beauty of scan to BIM. BIM is about integration. It's about working in 3D. And it is a really, really powerful tool. The next aspect is internal scanning. There's a lot of different technologies and different sensors we turn to. Drones are great for the outside, but they're not necessarily the best tool to use on the inside. And what we really believe in is an integration of a multi-sensor approach. So internally, we can now start doing digital replicas, digital twins, and optimizing the way we can analyze and model that data. When it comes to doing inspections, the same workflow applies. We can start doing things like overlaying design data as built versus the information you're getting from sites. We can start doing close-up inspections of infrastructure, of steel sections, of the paint condition. What you can see on the left here is using some of the latest in smart AI technology, where you're picking up clashes, where you're looking for tolerances during the design stage. So a lot of other tools are available. I'm not even going to go into them, but there's really exciting drone tech and remote sensing technology that allows you to go anywhere. These days, we're flying drones underground. We're flying them in pipelines, in boilers, in smokestacks, in cooling towers. And the drones have gotten so smart that they are pretty much crash-proof. I mean, if you look at this bottom drone here to the right, you've got drones that can now navigate themselves without any pilots being involved. So monitoring is one huge aspect which moves away from the design stage. And this is really about digitizing your construction sites, turning it into a
I'm going to have
digital
to
replica.
just let you know you've got 1 minute left, eh?
I'm going to quickly fly. Engineering inspections is another major aspect, and really what this is about is taking the infrastructure and turning it into an ultra high resolution replica. Why it matters is about compliance. There's regulations for why it's important for an asset owner to monitor their infrastructure. They're legally obligated to do inspections on an annual basis. There's lots of applications starting with roofing. This is using thermal technology where we can pinpoint leaks on rooftops under waterproofing membranes, huge cost savings and optimizations. When it comes to external audits, you're looking at rewriting the rules, reinventing the way that this was done. This is a quick intro to what an actual digital replica looks like of a site. Here we have a smokestack, and you can see this is in real time. This is in 3D, and it gives you a new way of interacting with that information, a new way of visualizing what is actually going on. We've applied this tech on many different types of assets, in industrial, in commercial. The next thing I'm going to just jump forward is in bridges. The bridge management system has been forever changed through Sunrail and many other entities that are adopting this tech. This is a digital replica of a bridge. And it means that you no longer are closing highways down. You're no longer taking weeks and weeks on site to inspect, but you're rather doing it digitally. And you're doing it with much better information and more powerful tools than you had access to before. Dayle, I know I'm short for time. One quickly touch on a few other aspects, which is AI. These days, computers can do a lot of the analysis for us. Computers can see things better than humans can and can do it much faster. The way that we report on the information is different. The way that we can transfer that information is really powerful. Very quickly, thermal tech has also changed the game. Thermal technology allows us to look inside of materials to understand internal corrosions through spatial air pocket analysis and many other tools. The accuracy we get in quantification is hugely accurate. Reporting has changed, and the way we deliver tender documents has changed through the process. Very quick other applications. I think, Daryl, let me stop there and I'll go into some of it a little bit later.
Yeah. Thank you,
Sure.
Darryl. And I know it's very difficult for you to keep it within time management sometimes.
I'm never good at that, no matter how hard I try.
No, but really, Darryl, thank you so much for that amazing input. I must say the work that we've been doing is very exciting, and I love sharing it to the people to show them what the possibilities are. It's like watching the Jetsons and all of a sudden seeing what's possible. At this point, I would like to hand over to Richard and Louis from Aurecon, who will be discussing the work that they've been doing specifically around drones and how they've integrated into the engineering workflow. Richard, Louis, if I can hand over to you guys.
Yeah, sure. Thanks, Dayle. Yeah, so I'm not going to spend a lot of time on introductions. So we used to be Aurecon Africa, launching at Zutari now in next week. And we are one of the ROC holders that was referred to as one of the 60 that was referred to earlier. So between myself and Richard, we run the operation. Both of us drone pilots. Richard more experienced on his experience was more on the design side. Mine is more on the construction supervision side. And the combo of that makes for quite a good team. So yeah, the image at the bottom is some of the drones that we fly. We fly what we used to be called them the Toyota Corolla. So they're not very fancy, but they get the job done, and we know how to fly them and how to get a lot of value out of them. Yeah, so Richard, over to you.
Thanks, Louis. So folks, just really tagging on to what Darryl was saying, I think the common denominator behind all things digital is really information. And it's about how we as engineers and professionals in the built environment are interacting with information. And so a big part of that in today is about how we leverage different technologies. So the poll at the beginning was about, what type of CAD do you use? And one could actually rephrase that and say, are you still using CAD? And I think that those of us who are thinking that 3D CAD is the way to go, that's maybe an intermediate step, but there's still quite a ways to go into actual 3D modeling and BIM. When we talk about reality capture, again, quite a bit of overlap with the previous chat, but drones fall into a broader category of reality capture. And like we said, photogrammetry is the principal mechanism that a run-of-the-mill drone would use to generate 3D imagery. And it falls alongside laser scanning, which I think most of us are familiar with. But then emerging is also the Internet of Things, so sensor-enabled assets, and also using mobile phones. So there's quite a lot to watch in this particular branch of what SAICE is looking at.
Yeah, so what does a drone consist of? And it's actually very easy. A drone is a flying camera, and that's basically all it's got. All of the rest of the parts is just there to keep it safe and keep it in the air. So very basic principle of the drone. And they are good for a few things, and they've got a few weaknesses as well. They are quite cheap. They're stable to fly. You look at the vertical takeoff, the kind of quadcopters, they can take off in a small area. Great photos, great videos, highly portable, and it gives us rapid results. So you fly today, you've got a result tonight or tomorrow to give to your design team. Weaknesses, highly regulated, and we're going to touch on that a bit later with the ROCs. Limited flight time, 20 minutes in the air for the standard kind of drone. They only fly in the day. They don't really fly well when it rains, and you need quite a lot of permission. And there's some limitations, flying over people, flying over traffic. So it's not like they can just be deployed anywhere, but still a lot of value and easy to use.
So it's interesting. The idea of photogrammetry and survey is often brought into the same conversation. So our purpose of using drones in-house, we have a corporate ROC, which means that we don't sell our services to anyone else except ourselves. And we've really realized the value of drones in filling a gap. And that gap is very specifically bridging the space between having poor data and having excellent data. And the poor data that I think most of us are used to is, Google Earth, or no data at all. And then the excellent data, according to our engineering standards, relies on rigorous survey processes that are signed off by a professional surveyor. When we look at that in context of the design workflow, pre-construction, there's a lot that happens in the months before we go to tender and before we start construction. And the value that we see drones offering our projects is in bridging this gap. We can deploy a drone very quickly to site, gather good information that is good enough to do our concept designs. It might not be pinpoint accurate. You're still looking at a couple of centimeters error in most cases, but it's good enough to get the design going. And then when the time comes to move into detailed design to replace that reference data, and we're finding that workflow really works effectively on our projects. So drones are good in our world. They're good for taking photographs. There are other drones that carry laser scanners, which are amazing drones, a little bit above our price point. So we're really leveraging that little drone there. That's a picture of our actual drone in flight. And we're getting the most done that we can using that technology. We take photos, we process it just like Darryl explained, and then we export it into various different formats and take that into our planning and analysis. So as an example, this is a job we did in Lesotho. What you see on the left-hand side is retained earth embankment. Right-hand side is the side of a mountain. And in the middle is erosion. That gully was deteriorating rapidly over time. And the assignment was to design the concrete works to line that channel. And the surveyor was really having a tough time with conventional methods. And so we decided to send the drone in. And we took about 270 photographs up and down. And believe it or not, this was with a little Mavic Pro, a little fold-up toy drone just about. And with that, we were able to build this three-dimensional mesh model. And so on screen, each of those green dots represents the location of where a photo was taken. That information we then exported into a three-dimensional surface. And those are 10 centimeter contours, which were then brought into Revit and Civil 3D. And between those two softwares, we were then able to do a very detailed concrete design. And we work in 3D, so that's the way we produce our plans. And then got to construction, and you can see the result. The feedback from the contractor was overwhelmingly positive. Just the degree of accuracy that we were able to achieve in our designs, and also the way that we were then able to interact with the design information between the team sitting in Pretoria and this project sitting 7 hours drive away. So really, really effective use of the technology. Louis.
Yeah. So one of the other places we've been deploying drones on active projects, stockpiles, always a big element when it comes to cost payment, interim payments, and using a drone for material measurement is a no-brainer. You spend on a site like this, 40 minutes on site, a few hours of processing, and you've got very, very accurate results. In this specific case, we actually had a surveyor on site. We took the drone and he took the conventional methods, and on the stockpiles we had a 3% and a 0.3% discrepancy, which means just it is the accuracy is more than sufficient for going through that kind of exercise. On another project here, with the retaining, where they were busy building a retaining wall, the mudstone started, obviously once they started excavating, exposing it, the mudstone started falling off the face, which meant it was quite dangerous to actually access it. We used drones to map the face. We provided that information to the design team, which was actually able to come up with quite a quick fix and accurate information, accurate quantities, which again helped the project and increased the timeline on solving this problem quite rapidly.
So whenever you've got a new shiny piece of technology, the question is always, what can you do with it? And I think that oftentimes the way we engineers approach things is, you know, when you've got a hammer, everything looks like a nail. So when we started this endeavor, we really had to take stock and say, well, what are we actually going to use this technology for? And these are the things that we've identified that really add value in our business, is understanding the way that information interacts with the various different processes that we run. You can all read that for yourself. But critically important when you're looking at any type of technology is to understand that technology is an enabler for a changed process. And so we focus a lot on understanding how we work and then adjusting our workflows so that they would be able to make beneficial use of technology rather than push technology at all costs. So I think that's just a really important takeaway for all on the call.
And as we mentioned earlier, drones are also good for some very nice videos, some great marketing material, and just capturing projects at various stages. Where it was earlier mentioned, the different technologies. In this specific case, we integrated the laser scanners with the drone technology on a project to actually have that inside, outside, top side kind of view of the project all in one, merged together. And it becomes a permanent record of exactly what is the status of that project, and it becomes undetestable. I mean, so this is a point cloud, again, major cutting, getting that point of view is valuable to a client that sits in an office somewhere that doesn't get out to site, except for maybe the PM, and it gives them a view of where their money is going and what's the status of their project. We've used this to, in this case as well, drones on the outside, scanners on the inside, to start mapping assets that there's no details, nothing exists, there's no plans for these assets that the government or other clients have. So again, rapid information capturing while the thing is live. Again, huge sites, one day on site, and we were able to go from a Google Earth image to a good enough layout for a design team to start with a concept design. So you can see it's quite a large area, again with the Phantom 4. And if you zoom in, the detail is enough with the contours to understand the lay of the land.
We also had a look at bridges. Daryl, I think your technology is fantastic that you're able to process. We wanted to see what you can do with the Phantom 4 and Pix4D. And in particular, we wanted to see how could we actually push this to get 3D. And so the point cloud we got for that bridge was pretty good. And our Revit modelers were able to then take this and do a retrofit of the actual bridge structure, which is phenomenal. And I mean, if you just look at that site, it's straddling a river, very difficult to get equipment up close. And so being able to fly is really a bonus. The other thing, obviously, is close-up photographs. And this is kind of the dumb use of drones, but it's very effective, is just being able to use the drone like a camera on a very long selfie stick, and being able to get that camera into an awkward position and take close-up photos of, in this case, the bearing pads, and being able to see particular damage which you wouldn't be able to see any other way unless you literally abseiled over the side of the bridge. And so, again, from a health and safety point of view, very effective. And then just getting all of those images. You mentioned digital twins, and obviously a big part of that is having a vivid visual representation, not just on models, but also on supplementary information in the form of photographs. We tried we're always, in the last 2 minutes to wrap up, we're always pushing the extent of what we can do in a short amount of time. So we gave ourselves an hour on site, and so in 45 minutes we captured enough images to map out this interchange. And what's really great about the photogrammetric process is you've got 3D at the same time as your 2D. And so this type of information, when you pull this into open roads or civil 3D, we're able to then immediately start with concept design. So I think we're gonna leave it there, and hand over. Thanks very much.
Richard, Louis, thank you so much. It's really exciting to see the work that you guys are also doing. And I know that you guys being one of the first engineering firms getting your corporate ROC, you guys are really leading the way. And it's really exciting to see that you've been applying it so well. To our attendees, just a quick reminder, guys, please do post questions in the Q&A tab, because we will be setting 20 minutes at the end of this to directly answer your questions, because I know that you guys probably have a lot. So please feel free, throw in a whole bunch of questions. While the panelists are discussing, I will go through and basically take 1 or 2 questions that are most relevant, and I'll try to get as most of them as possible. And yes, after this also contact details will be shared. So if you have any direct questions, you can also direct it at them. It is at this point, I would like to hand over to Mr. Harli, Technical Director at Jones & Wagener, and also one of my clients. Grant, over to you.
Yeah, thanks, Dayle. Yeah, it's a real pleasure to be with you, albeit virtually. Yeah, thanks for the introduction. My name's Grant Harli. I'm Technical Director and fortunate enough to head up the Structural Engineering Division at Jones & Wagener. I'm just going to share my screen with you. Give me 1 second. Go into my PowerPoint. Okay, just give me a thumbs up if you've got it. Good stuff. Okay, so yeah, let's just quickly talk about our experience using drones. And firstly, just to kick off, let's give credit where credit's due. This isn't a marketing slide. It's really just to show how we had different players coming together to make this project a reality. Firstly, I'd like to thank our client. You know who you are. You asked to remain anonymous, so we won't mention who you are. Secondly, iGlobe, who actually flew the drone for us in this particular case. They did all the data acquisition. There's another company called Urban Soup that we utilized. They helped with the virtual reality capture and further post-processing and digitization. And then Delta Scan also helped with the post-processing and development of 3D models. So we all came together, made this thing happen. I think it's important to point out, like as Darryl said, they aren't drone operators, but they offer a very specific service. We offer as Jones & Wagener a specific service. So do the other people on the screen. And coming together, you can really create some really interesting products and deliverables. Okay, so in a nutshell, what we were tasked to do is we were asked to look at using drone technology and whatever associative technology we would like to use as a proof of concept for conducting a number of studies on a smokestack. It's not the smokestack that Darryl showed earlier, just to let everyone know. So the smokestack that we looked at is a whopping 301 meters high. That's enormous. If you think about it, it's 4 or 4.1 to be exact. Airbus A380s. Those are those massive jetliners stacked on themselves from tail to tip. And it also wins the prize, and South Africa should be proud of this, for being the 3rd tallest structure in the Southern Hemisphere. just anecdotally, the drawings actually show that the stack is 300 meters high. But someone who's been at our client for many decades told me on the side that it's actually 301 meters high. And why that happened is while they were building it, word got out that there was something else being constructed that was 300 meters high. So they wanted to just give it that extra push and get the badge. So they made it 301 meters high. Whether or not that's true, I don't know, I can't say. But the structure on the right is the Gran Torre building in Chile. That's 300 meters high, exactly. So we're a little bit taller than that. And then just for local contextualization, I don't know if anybody knows the Leonardo in Santon. That's I think 254 meters high, if I'm not mistaken. It's the tallest building in Africa. I was actually fortunate enough to be in the same master's class as the lead engineer on that building. So James, if you're listening, I'm still bigger than you. Okay, so just quickly, I just want to share with you 3 reasons why I think drone technology post and pre-COVID, really are essential tools for engineers going forward. What you're looking at the moment is the actual stack, or a portion of it rather, and that tiny black thing up there is the drone. So that little guy worked for about 3 days to do all the work, and it was successful. So just to give you some context, a little drone like that can take a lot of photos very quickly. Just also quickly, Dayle, a thumbs up. Is my audio coming through all right? Great. Okay, let's move on. So yeah, the first reason, really, when you're doing condition assessments on tall structures, typically there are 2 approaches. Firstly, you can kind of stand at ground level, and using a set of binoculars like this guy, you can try and conduct the visual assessment, and you walk to nearby structures, you climb up cat ladders, you try get to every possible place that you can. It's great, but obviously for most of the time you're far away and you're missing the details. The second approach is to use some qualified rope access technicians, which they certainly still have a place in the market, and they play a very important role. I don't want to kind of say that they don't, they really do. And what they do, though, is they give you a kind of close and intimate kind of view on the concrete. I suppose only an engineer can use the word intimate and concrete in the same sentence. But anyways, that's what they do. And at the end of the day, you're faced with 2 extremes. You have this really far kind of view on the whole stack, or you right up against the thing. And there isn't this kind of in-between phase. And it's touching on what Richard said earlier. And just for all the listeners, Richard and I didn't coordinate our beards before this discussion, I can assure you that. So anyways, that's why they're very, very useful. So just by example, this photo that you're seeing now, there is absolutely no ways that you could get that kind of contextualization with anything but a drone. So it's that visual access that I'm talking about that's really, really useful. I don't know if you can see your house from there. If you can, well done. Okay, so just moving on, that's the first one. The second one then is to do with the detail that we're getting. And this is where the magic really starts to happen, in my opinion. Delta Scan, who do the post-processing, they're able to combine these photos into ultra-high resolution facade maps of the entire structure that you're looking at. And I want to quickly pop out of PowerPoint and show you. Hopefully it's going to work. And this, as a structural engineer, is immensely, immensely useful. So let me just quickly try to do this. Pop out of PowerPoint. Okay, Dayle, give me a thumbs up if you got my facade map. Great. Okay, so this is the stack that we're looking at. And if you think about it, especially on a big oil, petrochemical, power plant, whatever you're dealing with, there's no ways that you're going to be able to get an overall view like that. And this is a series of photographs that have been, digitally stitched together on a 3D model. But the actual resolution is mind-blowing. So I'm just going to zoom in. And you can see I still haven't got any fidelity loss at this stage. Okay, and then now we're starting to see kind of the magic. So I can clearly pick up old places where patch repairs were done. You can see there, over there. Hopefully, I don't know what resolution this presentation is coming out at you guys. It's probably 360p, I'm not sure, but the resolution is really, really fast, phenomenal. There's no other way to put it. It's really exciting. So you can see there's been a lot of loss of fines due to the environment around the side. Around this light well, there's clearly been some patchwork. And as an engineer, you can now get a view on the whole structure and really see what's going on. I just want to look at some other couple of things here. You can see in fact, you can even make out the panel formwork where you had grout loss occurring while this thing was being constructed. Just looking around at some other things. Here's some patchwork. Clearly that's failed. You've got some cracks going on there. So with carbonation and water ingress, that's just going to get worse over time. And you can identify it, you can measure it. It's all there in front of you as one facade. We've actually got all 4 facades. And if you wanted to, you could actually do like a UV unwrap the whole thing. So it's one flat image of the entire circular structure on your screen. Really powerful stuff, really, really useful if you're planning any kind of refurbishment work or assessing or trying to come up with quantities of refurbishment. So yeah, that's that in terms of the second reason. Let me just quickly try pop back into PowerPoint. Okay. Okay, so really that's nice. Then we actually took it to another level. So with the help of Urban Soup, what we were able to do is, and I'll hopefully demo it, is we were able to create a virtual reality experience of the actual stack. So it's not a 3D model that you zooming around a point cloud, or not to say that that stuff isn't useful. It is hugely useful, but as soon as you step into a virtual space, it's a completely different immersive environment. And that has its pros, but over and above that, once you're in that 3D space, you have the actual defects that you're trying to find within you, in your face, and you can plan things very easily because you have all the infrastructure surrounding. So obviously I can't show you the virtual reality, but what we did is we created an exe file, an executable file that we handed over to our client, and we said, here is your smokestack. Now that exe file is completely software independent. In fact, I'm going to show it to you. I'll run it on my laptop. Anyone can run it, and you can do it for any asset that you want digitized, you want a digital twin of. You can make this exe file. The controls to fly around it are very, very simple. And in fact, you know, you need absolutely no training. So let's just jump into that quickly. I'm going to exit my PowerPoint. Okay, Dayle, you've got my smokestack in 3D. Good stuff. Okay, so here we go. Here's the smokestack. So I'm just going to move my notes around a bit. Okay, so this is the actual smokestack now that I'm in real time. This is not a video, a pre-recording or anything. I'm shaking my mouth from left to right, and you can actually see it. So you look, oh, there's that A380 that we were talking about. So, you know, I'm now navigating around this thing at my desk, which is mind-blowing, right? In Johannesburg, looking at the stack that is hundreds of kilometers away from me. Now, I'm just going to fire around to see you. And you know, I'm not running a supercomputer of any sorts. It's a laptop with an exe file. I don't have any fancy software. So now you can give this to your clients and deliver it to them. It's just, you can see the surrounding infrastructure. So now if we had to plan refurbishment works and you handed this over to the contractor, you can clearly see, oh, where can I build my scaffolding? We added the birds, by the way. The birds were not part of the original scan. Obviously, there's an eagle. I'm not sure what an eagle's doing there. Anyways, so you can clearly see the use of having all this infrastructure surrounding the stack and trying to plan around it. You can go right up to this thing. And these textures, just to re-emphasize, I hope the audience is realizing that these textures are not a concrete texture that we kind of imported from a material library. It's the actual texture on the actual stack. So if I wanted to go to a specific defect, I could look at it, see where it is. Okay, I'm up this high. It's measurable. How am I going to get there? What am I going to do? So, yeah, that's the third thing. So, at the end of the day, what we wanted to do is show the clients that yes, we can use drone technology. It's definitely hugely viable, and we should use it going forward for condition assessments, for planning refurbishments works, understanding the context of the thing. So just quickly as a recap, the first and foremost thing is, you know, these drones give visual accessibility to another level. You've got my PowerPoint, Dayle? Good. Okay. You've got greater contextualization with less effort. These ultra high resolution facade maps, you can see all the defects in a single image. It leads to a more accurate assessment, better planning, and then you have an as-built digital twin that you can hand over to your client. They can strap on a set of virtual reality goggles if they want, be in the space or not. You can still use your laptop like I am and view this model anywhere. You could send it amongst your organization. So for planning, asset monitoring, and user friendliness, it's just huge. The application is huge. So yeah, just to end off again, these are our guys that we got involved, and yeah, it was a success. It was a proof of concept. So there wasn't an official, like the scope was a bit blurry. The lines were a bit blurred in terms of what the scope is, but we're continuing with it, and hopefully we're going to take it to the next level and develop it further. Yep. So that's it.
Grant, thank you so much for your input. I must say, it's always nice to have such an entertaining panelist as part of the group. Thank you so much for your input. And guys, I hope that now that we've got the input from the 3 different companies that are presenting today, your horizons are able to open up a bit to see what the possibilities are, that the Jetsons aren't 20 years ahead. It's now as we speak. Just quickly, Debbie, maybe if we can have the second poll, I think it will be a nice introduction into the next phase of the webinar. If you can please bring that up. Let's just wait for Debbie. Debbie, are you having difficulties showing it? Ah, there I see.
No, there it is.
There we go.
Thank you.
Guys, just a quick question. Really, it's just to get a feel and the opinion of the engineers in the market. Do you feel the current South African engineering workflow has welcomed the integration of new technologies, or has there been a level of general resistance? If you can please choose between the 3 different options. Has it embraced technological innovation? Is it a bit indecisive in its decision to integrate, or has it been a bit resistant to integration? I'll allow 30 seconds just to get the general consensus. Debbie, if you can please just give us the results.
All right, by the looks of it, indecisiveness in the decision to integrate is definitely coming out as the highest, with 57%, and embrace technological innovation is 27%. Resistance to integration is much lower at 18%.
Wow, I must say that's very interesting to find out. Maybe there's just a level of uncertainty around the levels of integrating this technology that's creating that phenomenon. Debbie, thank you for that poll. If you could just quickly remove it, I'll just move on. Okay, to get to the second part of our webinar, it's just a few spot questions, just that we feel are a bit applicable to the topic. Darryl, I'm going to address this to you specifically. I know we're speaking a lot about drones and digital twins, but do you mind just quickly speaking about a bit about artificial intelligence and how specifically that can be integrated into the workflow? I hope I didn't get you on the side there, but I just want to kind of give that part of the topic a bit of attention as well.
Yeah, so I know I was very pressed for time, but AI is really a significant part of the workflow. And there's a famous term in the market that goes like this: don't ever give a human a computer's job. And I really like it, and it has so much truth in it, because computers, when it comes to visual detection, when it comes to repetition, when it comes to speed, they can just do things so much better than a human can. And being an engineer, we train to look for certain things. If we're looking for cracks or rebar or corrosion or missing bolts, we can build data sets and libraries that we can train computer systems to detect just as good as we can. And the computers continuously learn. They continuously, or learn in inverted commas, they continuously get better. And the speed that they can operate is huge. Just to give you some insight into doing a typical inspection like Grant has shown you, the modern day workflow, digitizing structures that are 100 meters high, 300 meters high, used to take us weeks to see that much detail, to zoom in, to find out everything that's going on. It takes a technician a long time. The modern day workflow on average takes us around 5 seconds. We can analyze a building, we can analyze the defects on a full-scale structure to 98% accuracy in around 5 seconds. And that's the power of the tech. There's lots of other use cases for it around navigation and how the drones can fly, where pilots are no longer needed. Fantastic companies like Hovermap, Emerson Hovermap, design self-navigation systems for drones, where you can literally tell the drone to go, and it flies around the building and it generates beautiful coverage of that site. Dayle, does that answer?
Yes, no, really, thank you for that. No, I just wanted to add a bit of the artificial intelligence topic in there as well. I wanted to just push it on the side. I will redress that again. The guys from Aurecon, if I could please just ask your opinion around the digitization aspect of virtual site offices. And I think this is ridiculously applicable currently to the COVID environment that we are in. Richard, if I can maybe invite you to answer that question.
Sure. It's been incredibly topical with our construction unit. We've been talking about bringing the site back to the office rather than taking the office to the site. And, you know, I don't think we'll ever be able to get away from going to site. There's always going to be a certain amount of needing to be there and seeing what's going on. But I do know that the average site meeting involves a lot of people that travel a long distance, that need to then mingle, crossing provincial boundaries, who, if we brought the site into the virtual space, just like we're doing right now, we're actually able to eliminate a lot of that travel and at the very least reduce the number of site offices. So photogrammetry is a big way of doing that, specifically with large civils jobs. And there are a number of other types of reality capture, scanning and reference 360 photographs are two very simple ways to do that as well. And I think it really requires us as an industry to think out of the box. We're used to doing things a certain way, and that poll that we just did was really clever, because I think we think it's a good idea as an industry. We want to use a certain type of technology, but we haven't tried it, and so we hesitate. And I think that's happening across the board. So I'm really hoping that the audience, that what you're seeing today emboldens you to say, let's try this, give it a shot. And generally the technology of today is strong enough and effective enough to give us very much in the ballpark of what you would expect. And I think the risks are coming down tremendously in trialing this new technology. So let's do that. Let's bring those site offices back into the main offices. Let's reduce the travel. Let's get the carbon footprint down as well. Definitely something to do.
No, really, Richard, I really do appreciate that answer. And I must say that poll also caught me a bit off guard. And I really didn't think that the indecisiveness would be the reason for the lack of integration of this tech. But at least now we've got our answer. Louis, did you want to add to that quickly?
Well, I actually wanted to say that the other thing that we're doing with the virtual site offices, we're actually not just bringing it into the consultant's office, we're also bringing that site office into the client's office and into the
Yes.
contractor's office, where they've also got 1 or 2 representatives that see that project, and it opens up the world to them to actually understand the project, see the project, and just be more involved without leaving the desks.
No, definitely. I could tell you now, clients get very excited at the idea of, looking at their assets in the 3D space. Grant, taking into account what Darryl has mentioned and Louis and Richard, how does one bring this together? What does the future hold for the structural engineering division, and how does one see how will the technology affect the outcome? If I can just ask your opinion on that.
Yeah, so I suppose there's 2 ways of looking at that, really. The first is the side of fear, where you say to yourself, oh my goodness, all this cloud computing and big data analytics and design optimization is going to eventually replace the engineer. So that's that's one way of looking at it. But
yes,
you've got to take a step further. Personally, some of the things that I'm really excited about, and I encourage the audience to do this, is look up something called generative design after this. It's something that's been pioneered by Autodesk, and it's really going to change, I think, the way we make things, the way we build things, the way we think about building things going forward. Just as a quick story, I heard it from Autodesk. It's fascinating what they do. They actually took some kind of race car, and they wired up the race car with a whole bunch of strain gauges. And they teamed up with a group of guys, I think they're called the Bandito Bros. They're like some guys from Los Angeles that do stunts for big movies. And they said to them, okay, you're going to take this car, you're going to race this car like you've never raced it before. Take it around bends. I think they even took it around loops. And they really punished the car. And they brought in all this data, all the information from the strain gauges that were wired all around this car. Then they fed it into a computer, and they said, okay, using generative design, which just briefly is, the human brain can only conceptualize a certain number of variables. But as soon as you start leveraging the power of cloud computing and big data analytics and all of that, you can start coming up with designs that would be impossible for the human brain to ever conceptualize. So what they did is they fed this information, and they said, okay, using the restraints of, say, minimum mass, develop a chassis that can resist all these forces that were picked up during this testing. And the results are actually mind-blowing. What the computer produces at the end of the day is a 100% optimized, obviously for those given constraints, but it's something that almost looks organic. It ends up looking like, some sort of skeleton. Now, you combine that with advances in additive engineering or additive manufacturing, and you'll be able to produce things at absolute minimal costs, and the technology is available to anyone. So, gone are the days where you can have these big corporates that only build cars. We're going through it now. The crazy thing is we're going through it now. You just look at what's happening with SpaceX, and it's like mind-blowing that a commercial company has put a space rocket into space and docked with the International Space Station, which was like the realm of, never mind big companies, was the realm of countries. Now it's being opened up to everyone. So, it's really exciting. And I think that kind of space, generative design, leveraging on cloud computing is the future for structural engineers. Yeah, that's what I encourage the audience to really look that up afterwards. And I mentioned it just briefly, additive engineering, General Electric are doing really amazing stuff in additive manufacturing. Check it out.
Grant, thank you so much for that input. Sometimes I say that, if you want to innovate, you sometimes have to break the rules that you didn't even know existed. So I appreciate that input. Quickly, Aurecon, I just want to quickly discuss your corporate ROC. What has it been like? What is the experience like? As an engineering firm, having to take on a new wing into the company to basically innovate and get new levels of information. Can you maybe give us a bit of a rundown on how it's been so far?
Yeah, I think as a new
Dayle,
sorry.
Dayle, can you quickly stop screen share?
Yes, I will do so.
While you share the screen, As a new wing in a company, initially, as you guys know, adoption of technology, it was quite a struggle to get through all the loopholes, and unfortunately at the start, CAA did not make it that easy, but we stuck in there. The corporate ROC has really opened the door for us to become expert specifiers in the technology, being able to easily deploy the crafts, easily deploy the technology to a project. But yeah, it comes with the challenges, but and I mean, there's still quite a few rules of things we can and can't do. So in terms of a corporate ROC, Richard, if you can maybe go on there. Those are the kind of operations we can do and the places we can fly. So we can actually operate at national key points, and we can do a lot of things which is normally seen as not allowed when you use a drone. But again, then we're also not allowed to, as Richard mentioned earlier, we don't sell our drone services. We don't, at the moment, we can't tender for drone services because we've got a corporate ROC and not a commercial ROC. And yeah, it's something we're working towards actually changing into converting ours from corporate to commercial.
So I think some of the insights around operating, yesterday, Louis and I actually attended aviation security course at one of the aviation schools. And the comment that they made was that we're essentially an airline company because we're operating airplanes. And I know that sounds a bit funny, but Darryl, you mentioned at the beginning that we're intruding into the space of manned aviation, and that's exactly the point. So we knew what we were getting ourselves in for when we went after the ROC, and it has definitely proven quite a job to maintain that. There's a lot of admin, there's a lot of discipline required, and the biggest thing that the Civil Aviation Authority is after is safe, controlled operations, so that we know at any given time. So I mean, as we're speaking, there's messages coming in from our team in the Western Cape that have just finished flying, and just to pop up a photograph, that's one of our pilots that just completed his operations this afternoon to send a confirmation photograph to us. So it's really about staying connected with your pilots, staying on top of your fleet, and understanding exactly what's going on at any given time. So I think anyone who's considering an ROC, it's definitely worth it, but it definitely comes at a cost and should be carefully considered.
It's not quick.
No, Richard, Louis, thank you for that input. And I must say, from my experience, yes, it is a bit of a process, but yes, also rewarding. But also on that topic, guys, understand that there are 64 companies out there that you can contact to also outsource this, to capture data legally as well. So that's always an option. So let's not forget about them at the same point. Darryl, I think, just to allow for 20 minutes of Q&A, I'm going to just wrap up with you. Maybe if you can take us into like specific industry use cases that you feel that are applicable to the topic that we are currently discussing.
Cool, thanks, Dayle.
And please feel free to share screen. I know.
Okay, I'm not going to do a share screen because then I'm really going to get into it. But I just want to touch on a few significant areas. Because we're an independent entity, we see the market very differently to individual companies because we see it from a bird's eye view, and we get exposed to many different aspects of engineering. When I started out, I was predominantly focused on structures, and over the last couple of years, because of the work we do with drones and digitization, we've been involved in everything. We're working with companies that focus on pavements, specifically looking at roads, at bridges, at transport infrastructure, and the huge power it allows you to bring into that workflow. In the public sector, some of our biggest clients are actually government. I don't know if they publicly talk about their drone programs, but they've really embraced the technology. If you look at the departments of infrastructure, various departments are using drones every day, sometimes multiple times a day, to digitize their sites so that they can remotely share that information with teams that are all around the country. We've done it many times for companies that are based in Europe. Designers are sitting in China, project managers are here in South Africa, and it creates this new format of talking about your project. As Grant mentioned, Virtual reality is also a significant part of our workflow, where you can literally visit the site. You can be on the site, and a lot of the stuff, what I actually showed earlier, when I showed you the picture, the image of the bridge and that smokestack, the new NVIDIA technology, one of our big partners, allows us to do real-time, ultra-detail, zero latency streaming. A lot to take in, it's a big mouthful, but what that allows you to do is to share online super resolution models. It's one of our most favorite points, and it's changed the way that we consume this info. Very quickly on the mining side, huge adopters. One of the biggest adopters of digitization in general. There's many companies that run SIMS projects and many other aspects where the mines are focused on digitization. I won't mention names, but many mines have started digitization from the ground up. Other mines have turned to turning all their existing assets digital. A big term that's used in the industry is IoT, which is essentially connecting sensors to all your operations on site, which feeds into a dashboard. How we're using that is predominantly in the geotechnical space, where you're starting to deal with ground conditions, slope stability, monitoring dams and various types of earth retaining infrastructure, where you can get really powerful information about what is going on. The petrochemical industry, refineries, there's a very big international push into the space. South Africa is certainly a little bit immature in that area. They're really struggling to find their feet, how to adapt. If you have to go to a South African plant and offer them their services, you know, they say, wow, this is fantastic, but you know, how do we use it? How do we bring it into the company? How do we share this information? And that's really a big role that we play in the market, is bringing this in, becoming the new norm. On the international space, however, it's very different. Internationally, there is massive adoption of this tech, of drones, of technology. When you do presentations to some of the oil giants, you know, they see the stuff that we're involved with and other companies, and they say, where do we sign up? You know, straight away, that's the reaction. Commercially in South Africa, big companies, big property owners, facility managers are turning to the tech as well. And water as well. I see some people in the questions talk about pipelines, very big adoption in the water industry, looking at dams, looking at pipe networks. There's so much more I can talk about. I think let me leave it at that. And really, guys, I think the same is applicable for all of us. You know, send us emails, send us your questions afterwards. There's quite a lot of questions in the Q&A as well. I've tried to address some of them, but there's a lot more that we can maybe get to at the end.
Yeah, I'll definitely get to that. Darryl, thank you. And guys, sorry, I might be pushing the webinar a bit more, but there is a very crucial thing that we completely forgot. And it's actually a point that Richard asked us to raise, specifically around how do the standards in engineering workflows affect the integration capabilities of this type of technology? I want to make this an open question to all the panelists, but Richard, if I can maybe just start with you, since you brought it up, and I think it is actually quite a crucial one to answer.
Sure, thanks for that. So really, I think most of the people on the call know that in the work that we do as engineers, we have to adhere to certain standards and procedures in how we gather information, how we process things, and it relates to our ability to sign off on the work that we do. When one introduces a new way of capturing information, I mean, René van den Berg asked the question about what's the level of accuracy on the interchange surface. And that's a classic question. It comes up, how accurate is the data? Can we use it for design? Is it admissible as part of the final design documentation? At this stage, no, it's not. At this stage, you've still got to have an official survey. And that often discourages people, because a lot of the engineers doing pricing will say, well, that's a double cost. And so having an adjustment to standards to make allowance for a new type of technology to capture. I think of laser scanning, for example. I know that there are some of our authorities that will not accept mobile laser scanning as a means to capture road surface textures and rutting. And once again, there's technology that can do a certain job, but the standards won't allow it, so the adoption is low. So I think the point that I'm making is not how to fix the standard, but it is an observation that the standards are influencing the rate of adoption.
No, Richard, thank you for that input. And guys, look, I see the time is getting a bit tight. Grant, I wanted to also just quickly get your input on that, if I can please, just like 30 seconds. What is your take on the standards?
Sorry, Dayle, just the question again. I was reading the questions.
So basically, obviously, the engineering workflow is dictated by certain standards that are regulated. Do you think that they pose a resistance factor to integrate this level of technology, specifically around the questions of how accurate is this new data that one can capture?
Yeah, look, I think from a structural engineering point of view, I don't see any, regulatory or compliance issues as long as you abide by the bylaws and Civil Aviation Authority rules. In terms of accuracy for the type of work that we do, that point cloud information is more than accurate, and it's, you're not going to beat that other than sitting there with a set of vernier calipers on a ladder trying to measure the thickness of the flange of a column. So I don't see that being an issue.
Okay. No, Grant, thank you for your input on that. And I think it is time we can move over to the Q&A, just so that we can get a chance to interact with the audience a bit better. I'm seeing a lot of questions here around software. Darryl, do you maybe want to answer this one? What do you think is the best starting point when it comes to software, taking into account the third-party platforms that we all know too and well, your drone deploy Pix4Ds? How does one go about choosing the right software?
Well, thanks, Dayle. Very difficult question to answer because there really is so much out there. When we started doing this, we made use of Pix4D. They were actually, the first market disruptors. They changed the game of what data collection, digitization is about around drones. However, when it came to doing detailed work, when it came to doing structural audits and really getting that, what we go down to the sub-millimeter level of accuracy, if we start looking at hairline cracks, that's when those packages kind of fail. Pix4D, Drone Deploy, a lot of those packages were targeted at surveyors, and they still are, and they are fantastic. They really work well. It's also quite important to understand that there's two aspects that those companies focus on. We've met with their engineers many times. We've discussed it with them in the beginning because we wanted to use this information to do more detailed type of work. And we went to them and said, guys, you promised 3D, you promised digitization, but why doesn't it work? And what they told us is they focus on two areas. The one is simplicity, and the other one is automation. And because of those two factors, what they really do is their primary market is mass market adoption. They want to be able to put this tech in anyone's hands. All you have to do is buy a drone, which is extremely accessible. I mean, anybody here can buy the same drones that we use, even the big ones, and download a cell phone app. The apps are, I think, free as well, if I'm not mistaken, Drone Deploy and Pix4D. And overnight, you can kind of become a really powerful surveyor or good at, you can have the perception that it looks really great. But I just must give a lot of warning and advice here that it might look good, it might look accurate, but you have to really study it. You have to take it further and understand what accuracy is about. When you're doing surveys or mapping, you have to be professionally registered. I'm not a surveyor. We bring surveyors in for all the survey work that we do. There's things like understanding ground control, understanding your spacing of your GCPs, understanding what your error is going to be in your X and Y and your Z direction, because there's a lot of factors that come into play when you're doing this. When you start doing detailed work, there's other things you have to learn, like how to scale your models correctly, how to do vertical mapping. The data collection itself is another topic that there's not a lot of information on, but it's complex. It's not automated like a survey job is. And again, there's really powerful tools around that space as well, but you have to learn what the limitations are, and you have to really dedicate a lot of time to understanding the really special ways that you can manipulate the data. Yeah.
Darryl, thank you for that answer. Actually, brilliant. And Grant, maybe I want to bring you in on this one as an end user when it comes to receiving this information. Software aspects. How easy is it to use it, and how easy is it to integrate it?
Yeah, so I think just case in point with what we did on that stack is that, you know, we made it actually software independent. So there was no need for that. But you know, the majority of Autodesk applications now have the ability just to bring in any point cloud information or most point cloud information types. So in terms of interoperability between different softwares, that's also taken care of. That's not really a major issue. Yeah, I think the developers of the software obviously think about that all the time, and gone are the days of software being isolated and not open to the outside world. You know, everything these days come with APIs, and you can plug in and do your own things. So you know, I think that the information flow and the stuff that we get from the guys that we team up is great, and there's been no issues from a software point of view.
And Grant, I think that might speak to the poll that we just saw, the level of doubt in that level of integration that's available. I think that's a very good point that you raised. And I've been looking through the questions, and I've seen quite a few come to a very topic that people don't like to speak about, and that's price. Richard, Louis, the guys that have done the conventional way and are integrated, can you maybe give us your point of view when it comes to cost comparison of integrating this technology?
Sure. It's definitely not a rands and cents conversation. It's a trade-off conversation. So everything in digital is about workflows, quite simply. So when you're going to consider whether something is worth the expense, you're going to have to step back and look at the workflow, find out how you're going to change your methodology and your approach to the project in general, how you're going to manage the information, and how the design workflows are going to be centered around the information you gather. So we've seen it countless times where someone requests some mapping to be done on a job. The mapping is provided to them. They didn't anticipate how that information would then integrate with the design that they're actually trying to do. Only once they figure that out were they able to get the benefit. When you do figure it out, the trade-off is specifically around getting a head start on your project and being able to reduce the period of uncertainty while you would have waited for traditional surveys. I mean, that's Grant's stack example. The duration of capture that normally would be required would be weeks. And taking that down to less than a week, it changed the entire workflow duration of how the job would be done. And generally, when you're able to reduce your field work, you're able to reduce your overall project cost even more. So in my mind, reality capture pays for itself if you capture those efficiencies.
I love how you put it in the sense that, you know, look at the trade-offs, the areas where you're going to be saving, and not just the money you're going to be laying out. Darryl, look, I know you've got a lot of experience when it comes to the negotiation table around integrating this tech. Do you maybe want to give us your input on this?
Yeah, look, I think Richard got it spot on, and there are definitely limitations. I see also some of the questions, someone brought up insurance. We do a really huge amount of work in the insurance industry around collapses, PR claims, and many other aspects for different insurers, fire damage, storm damage. And, you know, I've sat at probably 30 different insurance companies' desks along the last couple of years. For the bigger stuff, you know, where you've got some meat on the claim, it certainly adds huge efficiencies, but it's not the technology you would use to look at a missing roof tile kind of thing. So you have to understand, and I get asked that a lot. I get called into a big insurance company and they say, can you fly the drone into the roof to look at the leaking geyser? And it's just not suited for that. In terms of survey work, I can say from experience, it is a huge cost saver. It is really a big cost saver because the drone can cover large areas really efficiently, very quickly, and cost effectively. And there's a lot of other technologies I mentioned in some of the Q&A about PPK and RTK, which is real-time kinematics and post-processing kinematics. Those are on the more advanced drones. We make use of them quite often. And what that allows you to do is it's another level of the GPS accuracy you can add. And What that gives you is pretty much centimeter level accuracy at all times that drone is in the air. When you utilize a basic drone like a Phantom 4 or a Mavic, you're typically out by 1 to 2 meters, and there's a lot of corrections that are needed to bring that back to reality. So when you start using the more advanced systems, there's a lot less ground control you need, so a lot less manual work to get that accuracy out of it at the end of the day. And I mean, we at the moment, Dayle, as you know, we're currently mapping 3,000 hectares with drones on a single site. We have another project where we've got 500, 600 hectares going, and it's literally a couple of days worth of data capture. On the inspection side, as again Richard said, massive cost savings, and that's for a lot more reasons than time on site alone. When you're comparing to rope access as an example, the first thing to realize is getting a rope access team to site is a health and safety nightmare. There's paperwork. Sometimes there's shutdowns required of the asset you're on. If it's dealing with hot material, if there's moving parts, there's a lot of factors that come into play. The second thing is the cost. It is very expensive to send 6 technicians down to anchor themselves on the structure, hang on there for weeks at a time. The other aspect, and this is quite a big misconception, this is probably the most important factor, is that a lot of companies or a lot of the market will perceive that rope access is more accurate. Because you are so close to the structure, because you literally can touch it and feel the material and maybe do some testing on that material, they think, well, it's got to be better than a drone. The reality is, with that workflow, what typically lands up on an engineer's desk is a report that is that thick. And it is made up of thousands and thousands of individual photos taken from half a meter away, because that's their perspective that the rope access team has. And then you have to digest that information and figure out, where are the cracks? How bad are they? How many are they? That's the worst thing, is getting a tender document together from that information. Where we come in to change that is, now that you can see things comprehensively from a distance, and you can still zoom into that same level of accuracy like Grant showed you, you can now change everything. That's really what disruption is about, is it's completely changing the way we understand the market and understand the conventional methods. Yeah.
Darryl, thank you for that amazing input. And I really want to wrap it up with one last question. And I think it is more one of the bigger philosophical questions around the integration of this technology, and also taking into account the economical and political climate South Africa currently is in. How does one integrate this technology, but at the same time retain employment? And I think that's one of the more dangerous questions to ask. So I'm going to make this an open question to any of the panelists who would like to answer this one. Grant, maybe let's start with you.
Yeah, I think technology is a double-edged sword at the end of the day. It depends how you're going to use it. Like most things in this world, engineers are scared that they're being made defunct with advances in cloud computing and so on, and automation. But at the end of the day, the computer technology, just stepping out of drones for 1 second, the computer technology pushes the designs, right? Now, the next person who happens to be on the scene sees that design and says, okay, I want to go one step above that. So although technology is making certain workflows much quicker and easier, at the end of the day, it's still pushing the envelope, and you're going to need people to push that envelope even further. So, yes, it replaces jobs, but at the same time, it creates opportunities. And you need to balance those. And I think it's very important for the audience to realize that, no, we're not going to be replaced by robots. Although, just as a side, again, just to encourage the audience, do yourselves a favor. If you feel like being freaked out by robot technology, Google Boston Dynamics, right? They are a company that spawned out of Massachusetts Institute of Technology, MIT, and the robots that they produce are just absolutely incredible. Anyways, besides that, sure, the robot technology will replace certain jobs, but we're going to be creating other opportunities. So I think it's important for graduates and young engineers to not be as scared of adoption, of pushing the boundary, of pushing the envelope. You know, we've shown what we can do now, but the question is, how do we take it to the next level? And people can, anyone watching this can take this to the next level. And I think it was the founder of Atari, the game company. He said, you know, everyone has a shower and has a great idea in the shower. So the difference between, you know, people that make a difference is those who get out of the shower, dry themselves and do something. So, you know, what I have to say with that is, you know, shower often and do lots of things.
No, Grant, thank you for that input. Richard, closing statements from you. Louis, you as well, just around that specific question, and then just kind of bringing the conversation to a close. Can I please get your little final input?
Yeah, I think tying in with Grant, I mean, yes, we are replacing certain jobs and so on, but 3-4 years ago, you couldn't get a job as a drone pilot. I mean, and now that's a job. There's drone trainers that need to train the people that's flying. So the guys creating the technology. So yeah, I think it's, like you said, we're taking away some jobs and we're creating others. And if you look at not necessarily in engineering, but on the survey side of things as well, you know, drones are replacing what they are doing, but they're morphing into, again, more solution-based kind of scenarios and so on, and not just you know, the old kind of way of walking around on the ground with a stick. But so they're also adding more value into our processes. So overall, it's still exciting, and it's I agree with Grant, is embrace these changes and grab it and make it part of the way you work from the start. You shouldn't be playing catch up. You should be trying to stay ahead of the curve with these kind of technologies.
People, process, and technology. Those are the three things that you constantly have to keep balancing. So that's the balance we're constantly doing at our offices, is to see how do we need to think differently about the way we work. How do we need to train our staff? How do we need to anticipate the jobs of the future? The truth is that these changes are going to happen whether we like it or not. Technology will continue to develop whether we buy it or not. The programmers, the people who are figuring out the algorithms, they will continue to develop them. So the choice is not, do we want this to happen or don't we want this to happen? The choice is, how do we respond to it, and how do we prepare ourselves and the kids at school now, the people who are going to be graduating from university in the next couple of years. How do we prepare them? And how do we focus on making sure that the jobs that they need to walk into are pre-prepared as well? So if we go back to that poll result, there's work to be done. Us on the call, all of us, it's our responsibility to make this industry mature. And it's our choice on how we get out of that shower and what we do with the ideas. Today you've heard a lot. And I really encourage you to talk about these ideas, embrace them, and make those changes.
Richard, thank you for your contribution, and Louis, thank you for your contribution to this discussion, and really great answer. Darryl, I'm going to leave you with the last baton as we run this race. We're about to finish. Can I please get your final say, and then also maybe just answer part of the question around employment and integration of new technologies?
Yeah, so I want to use a surveyor as an example, because that is the first industry that was really changed through drones in the broader sense. And when this tech came out, the companies started advertising that download an app on your phone and become a surveyor overnight. Literally, that was the kind of pitch. And the survey market, the industry that had studied for 5 years and have been working for 30 years, you know, they said, how on earth is this little piece of plastic in the sky with some propellers trying to attack my job? You know, what are they on about? And very quickly after that, you know, when these tools started coming out into the market, the case studies came out with it, and the proof of concepts and the results. And what they found is that the drone just is that accurate. It is so much more accurate than you would get from a conventional survey. As Louis mentioned, you know, doing stockpiles and pits and volumetrics, it can just do it better, and it can do it faster. And that creates a disruption. That is really how a disruption starts. And I want to also just share my screen quickly. I have it in one of my other presentations. This is a really nice definition that I like from a Harvard business guru. And he says that disruption displaces an existing market, technology, or industry and produces something new, more efficient, and worthwhile. It is both destructive and creative. And that's really what it's about. And what the surveyors had to do at the time is they had two options. They could either see it as a threat, you know, these new drone guys are going to come and take our job away, or embrace the technology. Everyone has mentioned the word embrace, and that is what it's about, because once you embrace it, it becomes a tool in your arsenal. It becomes something that you can yourself work with and do your job better. I mean, the surveyors we work with, a lot of big companies do the same kind of survey work, but instead of doing it manually, they do it with drones. They do it at a fraction of the price, but yet they can charge the same. So they make more profitability out of it. I just want to add one last thing, which is quite funny, actually. This is, I came across this in the last week. I always used to make a comment when I speak to surveyors, is that, you know, guys, a drone can do the investigations, it can do the surveys, it can give you the beautiful maps, but you're always going to have a job, because somebody has to set out the pegs, somebody has to set out the site, you know. So there's no way a drone is going to be doing that. And then I came across this video. Just want to make it a bit softer. So I don't know if you can hear me over the sound of the video. I'm going to turn it down. All of a sudden, a drone comes out on the market, taking the market by storm, which is a construction setting out drone. It sets out RFID, fully automated pegs using RTK systems to within 5 millimeters of accuracy. And this, again, is the next disruption that the surveyors are going to have to deal with. You know, it's another tool to have. This drone, you basically plug in your engineering drawings of all your sites, the boundaries of your properties, of your roads, of whatever it may be. At any time, day or night, you basically plug that into the drone and you say, set out my construction site. And that's just, yeah, that's the speed of this technology. It's evolving constantly. It's amazing. It's fun. And you really just got to keep your eye on the ball and embrace the stuff. I think that's what I'm going to close with.
Darryl, thank you very much for that very humorous conclusion. It just shows, you know, you think you're ahead and then somebody comes knocking on the door with a brand new thing and you have to completely relook at how you do things. But I guess that's within the nature of integrating this type of technology. But ladies and gentlemen, panelists, attendees, I just really want to say thank you for taking the time to attend to us. I know we 8 minutes over time, so Debbie, I do apologize for that, but I really tried my best to keep it within the constraints. I really think that today's discussion was really good. I'd like to see this happen again at a future stage, maybe again with a bit more diverse panelists, maybe a bit more time allocated if that is allowed. And yeah, guys, again, I really do appreciate your input as panelists. Really, I love the work that you're doing in pushing the boundaries, educating the market. And I would love to see where we are in the next 2 years and measure the performance. On that note, Kevin, I'm going to hand over to you.
Sorry, I just had to shush my family. You know, I mentioned this earlier, that amidst the COVID-19 epidemic, it might be careless of us looking at opportunities, but there's an example I want to just highlight. During the SARS epidemic, one of the accelerators for adoption of e-commerce in China was led to the rise of Alibaba. I mean, they looked at the situation they were in, and they provided disruption in that industry, and they were successful at it. And I think that we should embrace new technologies, considering the worldview that we are presented with. We need to be prepared, have preemption, be growth-orientated, and move towards long-term transformation. And we need to reimagine our business and our operating models and service offerings considering new technologies. I must thank my panelists for your time and willingness to share your expertise and knowledge with us. And as a member of the SAICE IT Division, I thank you as well for attending this webinar. And we will continue in our efforts to provide the industry with insight into the adoption of new technologies. Thank you.